Hello and welcome. I'm Mohammad Sadman Choudhury and this is my presentation on stack, queue and tree. So what is a stack? Well, a stack is a data structure that's similar to a stack of papers in real life. So if there's a stack of paper and you put in a new paper, it goes on top, and if you take out from the top, the paper you put in last will be the one you take out first. So in data structure, a stack is the same way. So the data you put in last will be the one you take out first. And another thing to note is that the operation of putting in data is called a push, and the operation of taking out data is called a pop. So I have a visual representation prepared for this. Right, so this is a stack. As you can see, first we push 12, then 23, then 34, then when we take out, the one on the top is taken out. So this is what we're gonna do in code. Let's try that. 12, 23 and 34, right? 12, 23 and 34. Now if we print it, as you can see, the one we put on last is the one on top. So now if we pop it, then the one on top should be removed, which is 34. So we pop, as you can see, that's 34. If we print it, it should print 23 then 12. And yeah, that's as expected. So that's stack. Right, if we have functions for push and pop and for printing. So now let's move on to queue. What is a queue? Well, a queue is similar to a queue of, let's say, people in real life. So a line of people in front of a ticket counter. So in this case, a queue is the opposite of a stack. So the data that goes in first is also the one that comes out first, which is why it's called first in, first out. I have a visual representation prepared for this as well. Right, as you can see, first we have 11, then we have 12, then we have 13, but then we remove 13, which is the one we added last, is not the one that's removed, but 11, which is the one that was added first, which is why it's called first in, first out. So we're gonna copy this in code as well. Alright, first we add 11, then 12, then 13. Now we print it, as you can see, 11, 12, 13. Now if we delete it, 11, which is the one we added first, is the one that should be deleted. And yeah, 12 and 13, oldest item deleted. So that's as expected. So now let's move on to a tree. What is a tree? A tree is a data structure where there's nodes. The nodes can have data and 0 or more children. So here we have 14 has 2 children, which is 2 and 11, and all of them can have again children as well. So 2 has children of 1 and 3. So that's what a tree is. And again, I have a code prepared for this as well. Here, as you can see, first I make a tree with 14, then to the left of root I add 2, then to the right of root I add 11, then the left of left is 1, then the left of left, then right is 3, right, 3, and that's how it goes. I made this tree in code. So now let's run it, and again, since a tree is a little more complicated, there are more than one ways to traverse it. In this case, pre-order, in-order and post-order traversal. So a pre-order traversal is when the root is printed first, then the left child node, then the right child node. So let's have a demonstration of this. Yeah, so the root is 14, so that gets printed first. Then it goes to the left, and the root of left is 2. So 2, then it goes to the left again, which is 1. Then it goes up and back to the right, which is 3. So 14, 2, 1 and 3. Then it goes back up again, and then to the right, which is 11. Then the left of 11 is 10, 7. So 11, 10, 7. Then from here it goes to the right, which is 30 and 40. 30 and 40. So that's 3 and That was my presentation, and thank you very much for watching. Goodbye.